So we are still on the. Where are the others?
The order.
Oh, Loro Sokoto. Okay. Now in Scratch, how can you write a program to do this? Does this fit into an algorithm? Who can write the algorithm that does this? Who thinks this is a good algorithm? And is it a loop? Can you write a loop to do this?
Yes.
So what is this? Now, let's look at where they started. They started here and they move a distance. So again, start and then initialize a position and then forward. They move forward some number of steps. Forward maybe 10 steps. And then what happened after they move forward?
Upward.
That's not upward, called turn. It's not, they did not just move upward. How do you just move upward? Move forward, you just move upward. First you turn. Turn how many degrees?
90 degrees.
Turn which direction?
Like that.
Yeah, I'm head. You are moving like this. To go up direction is what? There's no up. Left, right. As you're facing a position, you go left, right. What is up? There's no movement up. It's left, right. So you go left. How many degrees? 90. And then you do what? Forward. Forward. Longer than before. So whatever variable that you were doing to move forward, you have to take that variable and probably add, because that distance is longer. So the distance are going what? Longer and longer than each other, right? So this was forward 10. So this should be forward what? 20, like that. And then what happens? You turn again, left, and then forward again, turn again. Each time you're turning what?
90 degrees.
Each time you're turning left or right?
Left.
Left. Have you not seen that each time is left turn? Eh? You move like that, this is your left, you turn left. You move like that, this is your left, you turn left. You move like that, this is your left, you turn left. You move like that, this is your left. Have you not seen that it's left? Young man. Casablanca. So again, visually, if we don't do visual examples like this, our critical thinking and problem-solving skills will not be improved. Eh? Are you seeing that you are turning but left?
So, all the codes in rectangles.
Huh?
All the codes in rectangles.
What are other codes? What's other codes? What is code? Edges. Edges or code? Don't kill me here. What is rectangle? There's no rectangle here. Say, are all the edges right angles? What is a rectangle? Is there a rectangle here?
What's the question?
What's the question?
Let's put it like this.
Oh, you mean to put the codes there? It's algorithm now. Your beginning algorithm is it not round here? And these other ones are they are all rectangles. But if I list them like this, is all steps. So it doesn't really matter if you put it in that thing. That was just a visual thing. The rectangles here, they don't matter. If you put like this, is it not step by step? That one is visual understanding. The visual thing gets you to understand it because it looks cool. It looks appealing to the eye. So do you want me to be writing it all the time as if though it's very important? They are not very important. The important thing is the message that is inside. It's a step-by-step thing. Don't go there and be, oh, which one should I put here? Is it round one? Is it over? Is it this one? Would that stop you from writing the code in C? You go and see there and be saying which one is over, which one is. So that was just a good presentation of algorithm. So where do we go and program this? In Scratch. So we go to Scratch and don't change, go where? I should not change, I should go where? Back to where we were writing. So when I was writing, you were there just watching. All right, so we are going to share our Scratch. In our Scratch, we'll go and try to implement that algorithm to see how that loop will work. So even though it's the position that is moving, in this case, in Scratch, we can come and paint our own character. We can just paint a dot, or we can make that dot maybe a little bigger, paint that dot. So that's that dot there. So that dot will be the thing that will be doing the movement. Even though that dot looks much bigger than we would wish. But we can always reduce the size to like 50% there. Okay. And then here also to make sure that you start your dot at the center. Where is the center? Yes, we put it right at the center here. Good, so that we can change this to 0 and here also to 0, 0, 0, so that your dot can be exactly at the center of the thing. Then now we go back to our code. Then we go to extension and we bring the what? The pen tool. Once you have the pen tool, then now you can draft your thing. If we say we start a program, we always start our program with when flag is clicked. It's a very good habit. Even though in Scratch it's not necessary. You can launch an event from the keyboard when space key is clicked. So there are different ways to launch an event, but when flag is clicked, it's very good because it guides you. Yes, to know that if you have different programs, different keyboards to control different events, but the main one should be the when flag is clicked. So when flag is clicked, what do we want to do? We want to initialize. So we know that we are programming this dot. And this dot is like our variable. It's like we've already created the dot. So in C language, you go and do int num. In Scratch, you do what? You go and create an object. You start there, you created the object, then now we initialize its position. We can initialize its color. We can initialize its direction. So those are things that you can initialize. So you come here to initialize, you say go to position 0, 0, point to direction 90, and color. Do you want the color to set color? Set color to 0, or you want to set color to 50. So when you do this and we click the flag to 50, that's the color there. So you see that it's not the color that was there. So you set color effect to 50%. So that is your initialization. Then now you say, okay, if you start from this position, how do you go now and draw that spiral? So that's what we want to draw. Say, okay, to draw the spiral, I need to loop it. So to loop, It's not like you loop. So you check, you take your book, draw your own spiral, and tell me how many edges does it have? How many sides? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 17. So if you are repeating, you are repeating something 17 times. So that is exactly where your loop here in repeat is very different from C, where we're using while a certain number I. If we create a variable I, we start at I from 1. We say why I is less than or equal to 17, so that you'll be able to loop, and then you're changing that I by 1. So if I want to do repeat in C, I'll do while I create a variable I, why I is less than or equal to 17, then I do I plus plus inside the while loop, so that it will do it 17 times. So it means it's the I that is controlling it. So I can do repeat 17 in C programming like this. How do you do repeat 17 in C programming? To do exactly repeat 17 times in C programming, you have to first create a variable called int I, and then that I, you can start it from 1 like that. And then when you go in, you do while, and then you use this variable I to control how many times this loop. So while I is less than or equal to 17, and then you come inside the program, you do this, whatever things that you are running at the end, you have to do what? I plus plus, or I increment I by 1. So this is how you would do something like this, repeat 17 times. This is how you do it in C. So we can also do the same things that we do in Scratch in C. But it's just that there will be no repeat. It's while. That's the only keyword that we have. It's called the while loop. And then you control it using your I, and then your I is going by one step after the other. So exactly it will be 17 steps here. The first step, I is 1. Is 1 less than 17? Yes, it does this thing. Increase I by 1. It goes I is 2. Is 2 less than or equal to 17? Until is 17 less than or equal to 17? Yes. It adds 1 goes to 18. Is 18 less than or equal to 17? No. You finish. So you do this loop exactly 17 times. So this is the equivalent of the repeat 17 times in C. So again, everything you can do in Scratch, you can do them in C. That's what you should put in your head. All right. So that now your programming now is complete. So first, we move a number of steps. So that forward that we put there, forward was moved. So we move 10 steps, and then we 10 left. Now to 10 left, now you have your left 10 here. 10 left, and we say it was 90 degrees. You put your 90 degrees there. Next time, you also move 10 again and 10 left. Next time, move 10 again and 10 left. But that would not be, that is not what you need. You want it to be what? 10, the steps that you are turning. When you turn, the steps that you move will get bigger and bigger. So it tells you automatically that what you should have here is not a fixed number, but what? A variable. Move variable number of steps, and that variable is changing. 10, it will become 10, it will become 20, it will become 30, it will become 40. And Aquilolo, you're still thinking, can you make this number of steps inside here? Because inside your loop, you are writing only one line of code. It's like print num, and the num will always change. Num becomes num plus 2. So that it comes and print, the next num will be different from the previous num. Here is your number of steps. There, the length of those steps in that you're drawing, are they not different from each other? So how do you make them to change if you're going to move only fixed steps? So you move variable number of steps, meaning that we have to go and create what? So you go to Scratch here, and you make a variable, and you call that variable what? Steps. So move steps, number of steps. So you come here and you are moving the word steps, number of steps. Once you create a variable, you have to set the variable in the beginning also. Outside your loop, you have to set steps to what? 0. Jesus. Your first move here is 0. Hey, la rosokoto. Then now you come inside your loop. You have to change steps by what?
Like that.
So this is where you do your increment. So do you see how Scratch does steps equals steps plus step? Huh? Now is your ability to learn Scratch and C++ at the same time, is that helping you now to really see how two languages are speaking the same thing, but in their own style? Have you seen how Scratch is speaking the same language that C will speak with? Steps equals what? Steps plus 10. Or steps plus equals 10. You want to write steps just one time using a shorthand. So like this, program is finished. But now, if we run this program, pop, see what happened to the dot. Start again. Pop, 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 pop. And if you want to see how the steps will be going, if you put your weight here, 0.2 seconds, one chan 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 chan, you see how it spirals. Then if you want to draw all that, your pen tool is there to start first and initialize the erase all. And then when you move to all this position, there have to be a pen up after you finish your drawing at the end of your program, so that next time you're starting your program again, then when you come here, there should be a pen down immediately as you move here. So if you do that, and then pen size, pen color, all those are things that you have to initialize for good programming. Pen size 3. Well, if 3 is 3, then you make more than 3. Is that it? Hmm? Yeah, no problem. Now, questions. What if we want these lines of the spiral to be closer to each other? What changes do we make?
Reduce the steps.
Make steps to be equal to what? Huh?
5. 1.
Change steps by 5. Or initialize steps to 5. Which one? Okay, let's initialize to 5 and see if that does it. So initialize steps to 5. Hey, where are you? So if we initialize our step here to 5, let's see what effect that has on the loop.
It's 5.
Nothing happens.
So it's
The gap inside still remains the same if we initialize to 5. It only affects this first movement, which was just what? 5 instead of 10. It only affects that first pin. Change steps by 5.
You can also change this to 1.
Change steps by 1. Falcon says we should change steps by 1.
It seems like
Why is it thick like that?
because it's 2 plus 1.
Pen size 1. So you see that small gap inside. So it's like 1 pixel on 1 pixel on 1 pixel. 1 pixel is lying on 1 pixel. So if you change by 2, you should be able to see the gap of 1 pixel since your pen is 1. So you see a gap of 1 pixel.
Yeah.
That gap is a pixel thick. So that now, if you repeat this thing now, you can now say, let me repeat 200 times.
The pyramid is not.
You can see now a tunnel. Can you see how people draw tunnel? If you have an A4 paper, they say draw a tunnel. How will you draw the tunnel? Now A4 paper. A spiral. You go and draw a spiral.
It also makes a pyramid that is not there. Okay. It's 400 now. And what's it for? We set it from 0 to that edge there.
So if they say, let's draw a tunnel, and this is the entrance to my tunnel, I draw a, and then I find the center. I draw lines from the edges to
The center.
and then I use pencil and I color. These colors, I make shades. And then I make some thicker shades as this is the ground. So I make more thicker shades. Yeah. This should be the ground. So like when you enter into the tunnel, this line, this one is thicker. So that's how you're walking down the tunnel. And then these ones are the sides of the tunnel. The walls. The walls are going thicker. Walls. It's like you enter the tunnel with your car. And then now you can draw a car now here like this. Car.
Right there.
Going right down there. So it gives you an idea when you want to draw things. And then some people will draw like that, and that's a road. A road is getting from bigger and the road is going smaller inside. So, meaning that once you understand geometry, you can also okay. Then now, next challenge is how do you make sure that these two walls are green and then this up and down are red?
Change the color. Yes, sir. It's a set pen color too. And you put it so repeat
So
steps 90 degrees. You put the pen here.
So move steps, we go right, and then we come and set color. When you move, we set color before we turn up. So it means the one that going right, you set color. And then we come again and move steps again. So you have to do 4 move steps. So this, and this. So 4 move steps and change color. 4 move steps and what? And 90 degrees. 90 degrees turn. So we are turning by right, right?
Yes, sir.
Okay. And two of those colors should be the same. So this one, you give it the next color. And then we duplicate this one again.
Change color. Change color.
Then this color should be back to this other color.
So
So
this is a color picker.
and then we bring back this. And we bring back this. Before now, you increment by 2. Increment by 2 also.
Duplicate 4 times.
So the first under what?
10 degrees.
And then this one under
10
10 degrees before you move.
You have to cut.
You need another one?
Yes, sir. 2 other ones.
Variables. Change.
Steps. 2. And under 90 degrees. Under 90 degrees.
And then okay. So
It's not shaking.
huh?
Why is it not shaking? Just open it. Then this thing.
Because all these things now, these 4 things are all happening. So they're happening now very fast. And then your weight is only once. Your weight is only once in the beginning. Except you want to put weight inside middle again.
Yes.
So this one now looks.
This is the inside this one.
So those are your walls. Now
130. It's 1,500. 1,570.
yes, because you have now 4 things inside now times 4. So this one should just go back to 50. Eh? So you people are not even seeing. Now that you have 4 things inside here, then it should be 4 times what? 50. So give your 200. And not now 200 times 4 to give 800. So your steps go right up to 404. So we should be able to stop our step around here so that it gives a square. Well, not around it, just because the length and the width is a square, but the length and the width are different from for our screen here, because we have more x. X is 480 pixel, y is 360 pixel. So that's your road. Somebody enters into the tunnel, and then the exit of the tunnel is small there. Phew. So people want to learn drawing. You can start also doing your drawing from scratch, and then seeing how to use the power of loop. Using the power of loop. Now, what if we want to draw a circle?
Yes.
What if we want to draw a circle? A circle, the idea of a circle is so interesting that some people will still miss it. So we use this dot to draw a circle. And we position the dot in the beginning. You can do 0, 0 there, or you can also do it by code. So a circle has just one important information: the radius and the angles of 10. So if you're using go to a position for your circle, you have to go and construct a multiplication thing. Here you put a variable called radius. Radius multiplied by, if you get the radius and you want to find the base, is what? We did it yesterday. Something falling down the inclined plane, mg. One side is what? Oh, las sacramentos. You have the hypotenuse like this. This x side is what? This x is what? If this is your angle, theta, and then this is your radius, and then this is your y here. So what is the thing? Cos theta is what? Adjacent is what here? Y divided by r. So what is your y? R cos theta. R times. Then what is your x? If you don't even go and write the x, what would the x be? X will be what? R what? R what? R sine theta. So this is how you change your system from a radius and theta system to an x and y system. So now how to build it here? Here we have something called function of a function here. This one here. This. So when you bring this one, you can find what here? Sine. And then now we have to go and create another variable called what? Angle. And go. So sine of angle. So this one should be what? Your x. And then if we duplicate this one, we change sign here to what? So that side goes there and this side goes there. And this is exactly what you need to create. Now you understand it better. When we're dealing race games, this is how we're using the race games to turn better, to turn good turns. And you people, that's the first time I taught you people this. So now we just need a way now to do what? To set our angle in the beginning to what? 0. Set our radius in the beginning to what?
Radius.
To 1. 1 pixel. You know the meaning of what? What circle do you want to draw? 10. 5. You want to draw a small circle?
No. To 150.
Good boy. Yeah. So 150, meaning that it will be what? A big circle from here 100, because from here to here 180. So it will be a big circle like that. You don't even know the proportion of that thing. Huh? Put by 100. You are afraid of 150. The boy says a good one. So we take the boy's number. So, and then now, to go to the loop now and draw your circle, what type of loop you want to do? Once the radius should be big, and then you go into the loop, how you repeat how many times? Who can tell me how many times we repeat? Jesus. to draw a circle, what will you be repeating? How many times will you be repeating?
360 times.
Good. 360. And what will you be changing?
You'll be changing the angle.
The angle. And you start the angle from what? From 0. So you put this one here, and you just go to your variable, and you say, change angle by what? By 1. And you have to pen down. While we are doing that, we start by erasing all, and then we finish our program with pen up.
Set the color, size.
Set the color and the size. What's the meaning of what? You think about it. What's the meaning of you writing your pen is down? What's the meaning of this? Set pen color, set pen size. Pen size, you can just give it a good old 6. Pen color, maybe give it a good old red. Then let's go. So, because pen down was the first thing, so wherever we were going up, we already had that pen down to change. So if we do it now, then we don't have any problem. If I can't his eyes are just trained on it. If I can't train the eyes. So you are going to these positions. The only thing that is changing is what? The angle. Meaning that the distance to that point from that center, the distance does not change. That is the meaning of you affecting only the what? The sign of it and the cos of it. So only your angle, your point, this radial distance is the radius, does not change. Because this is the formula. Radius, x and the y position. But in its real representation, it's like this. If you want to represent it exactly like you see it there, it's like this. This is your radius, and that's your point, and your point is moving like this. Then each time you are just looking for your point. When we come down here is the x position. When you go this way is the what? Y position. Yes. And then the so-called opposite of a hypotenuse, and your angle is this angle here, the angle that you make with the up and down. So this is your angle of theta. So again, the opposite is your x position, and the adjacent is this your y here, which is this distance here. On the axis is this distance, but that's the distance here, and then this is your x distance. So that you see that opposite over r is your radius. So each time if your thing is moving around a circle like this, so you see that next time that this angle change, like next time so next time it moves here, let's say the green moves here to this part. So you see that if you come again in this part and draw the green to WhatsApp audio, you draw it here, you see that your x has increased, but your y has reduced. So because this angle here is bigger, this angle now here is bigger. So as the angle gets bigger, your cosine gets bigger, but your sine gets, your cosine gets smaller. Your cosine gets smaller, but your sine gets bigger. So as the angle increases, so as this point is going this way, this angle is increasing. So that's why your cosine gets smaller and your sine gets bigger. When it's 90, When it comes down here, the angle will be 90. And then when it's 90 here, cos 90 is 0. So you see that your y will be 0. But sine 90 is 1. And you see that your x will be the same as r. As sine 90 is 1, r times 1, r. So x gets its maximum number once it's here. So it will be at this position here. So that's why when you start there, it's 0. And when it's 0, when you start here, it's 0. That's why it starts here. It's 0. Cosine is 0 when we are up here because it is straight. Straight. And then cos 0 is 1. So 1 times r is r. So that's your y is r here, but your x is 0. So if you watch your x and your y position there, you can also go to motion and put your x and y position on the board. X and y position on the board. And then you do this. Jesus. Okay, so x position. Okay, when they start, I need to put a thing to slow them down. So we put you can put slow it here. Okay, so x, you see your x here, 10, right? So x is increasing. It started from 0. So I want us to go back again. You see, 2, 4, 5, 6. So your x is increasing. And your y is decreasing. Your y decreasing.
Yes.
And is your x increasing?
Yes.
Good. So why is your x increasing? Because as the angle is getting what? Bigger and bigger. So your angle is getting bigger and bigger. Your sine theta is getting bigger and bigger. And your cos theta is getting smaller and smaller. So that's also how you know relationship between cos and sine. Like that if you draw a triangle, a right angle triangle, that if you have a right angle triangle, as this your line slips, goes and slips, as this your line is going and slipping, so this is your line, as this your radial line is going and slipping, see, as this your line is going and slipping, you see that as this line is going and slipping like this value is going closer, shifting closer this way, but this way it is reducing. That triangle that it forms, that's why they call it right angle triangle. That triangle that it forms, this part that is going to slip, this part is called your cos. And this part that is lying down is called what? Your sine. So that is what you're tracking. So if you see sine and cos and you think that there are some, you see, this side that is sleeping, this your sine that is sleeping has increased. And this your one that is standing here has decreased. So that is what you're tracking. So sine and cos, that is what sine and cos, that is what they do. See? Right angle triangle. As your radial line is sleeping, cos is reducing. Sine increasing. And why is it doing that? Is because of this as it's going This angle is what we are tracking. So, so as it is going, this angle is getting closer to what? 90 degrees. But if you don't want to track, if you don't track this angle, you come and track but this other angle. Bigger, smaller, smaller. They are going to say. Now, if you track by this angle, this one was the sine. This one now becomes what? The cos. And this one now up here becomes what? The sine. Comprehending? You see? If it is this one, that is a sine. What is happening to the sine? What's happening to the cos? Opposite. So within 0 and 90 degrees, your sine increases while your cos
decreases.
If it is the opposite, your cos increases while your sine
Decreases.
that's between 0 and 90 degrees. So you see that the program continues. If we change this to increase it, we have to change this to 0.01. Increase the speed. So while you are running a program, you can even be coming here to be changing the speed. That is called dynamic running of a program. So I start a program. Pap is running like that, and I come here and I put 0.5. I say, hey, slow down. Then I say, hey, faster. Hey, faster. Hey, slow down. Hey, slow down. 4. 0.1. Hey, faster. So that's dynamic running of a program. You see. And if you go 360 degrees, you see that this area is a positive angle. This area also is positive
Angle.
But this side is negative angle. Because you'll be like, this way you'll be counting from negative 0 to negative 90. Here, negative 90 to negative 180. Here is what? Positive 0 to positive 90. Positive 90 to positive 180. So that's how we look at this. Again, your sine and your cos, they are nothing except the different hands of a right angle triangle. And see how those sides change as a function of radius sine that. As a function of their radius. Meaning that they can go from 0 to maximum radius. Now, if they are this way, from 0 to negative maximum radius, but this way the distance are negative. It's a negative direction. So sine can go from negative 1 to positive 1. Cos can go from negative 1 to positive 1. Depending on which angle you are looking. So this one can be sine when the angle you are looking is this angle. If you are looking at this angle, then this direction is cos. Depending on the angle that you're If you are looking at this angle, then this is the opposite one. If you are looking at this angle, that's the opposite one. Opposite is always the sine. So if you are looking at this angle, sine is what? Your y. If you are looking at this angle, sine is what? Then no time you can be confused. Which one is sine? Choose your angle. The adjacent is your cos. The opposite is your sine. Sine multiplied by your radius. Chop. Let's close. So you see, with now you can do all geometrical things. And to determine where position are. If you want things to turn smoothly, you have to use angle and position. For things to turn smoothly. If not, you just say, point to 45 degrees, move. You just move straight line. If you want something to be turning, make sure radius does not change. The only thing changes is what?
Okay.
All right. Hey. Okay. This one is there for you. So that was another interesting session for Scratch. Young man, time to go home.
Lisa, can you change the one? Why? Someone the making classes. My name is Coco. I can't see it. Because Falcon is popular. It's a right Falcon. It's not stop.
Bye.
This has to write my name.
You know how to do your long division now, right? How to make all of your times table by yourself. Don't wait for the teacher, right? You do it and you can do all your long division. More practice, you give yourself questions and you practice. And you show me next time.
Wait, let me write my name.
Oui.
Lisa, have you started the video?
Nope. Tu l'as confié de venir l'autre jour, non?
Oui.
Il n'a pas venu. Il n'a pas venu. Mais il t'a dit qu'il va venir.
C'est mon piqué. Ça leur se charge il dit qu'il avait dit qu'il va venir le soir. J'ai dit que donc toi tu préfères marcher dans la nuit alors que moi j'ai donné un rendez-vous que tu devais tenir. Il n'est pas venu laisser ton agenda.
Non, il est venu seulement laisser. Je croyais qu'il est venu étudier, mais il est parti. Je tourne le dos comme ça. Quick, off.
Sans te dire au revoir.